This lesson goes a little deeper into the capabilities of the affine transforms to perform rotation and translation. Once you see how it works, it's pretty simple, but stay with me here because it's kind of weird. This program uses a loop to draw several figures in a circle around the origin. Right here, the affine transform is initialized to a rotation of 1/16 of the entire circle multiplied by the loop counter. The first time through the loop, the rotation is 0 because the value of I is 0. The second time through, the rotation is 1/8 of pi, which is 1/16 of the entire circle. The second time through, the rotation is set to 1/4 of the circle, then 3/8, then 1/2, and so on. But before the rotation, the figure is translated 250 pixels to the right. Then the transform is set and the figure is drawn. The loop occurs 16 times, so the origin is entirely circled with copies of the figure. However, as you can see, because the origin is in the upper left-hand corner and the rotation is around the origin, we can only see part of the circle of figures. But rotating around the origin is only the default. You can actually rotate around any point you choose. This example is the same as the one I just showed you, except the center of rotation has been moved. Here, on the call to set to rotation, two arguments have been added. They are the x and y coordinates of the new center of rotation. Now, to make this work, before the rotation is applied, the figure is translated to a position 100 pixels to the right of the center of rotation. Remember, rotation works as if a pen were inserted in the center of rotation. So to have the figures rotate in a circle around the new center of rotation, it's necessary to place the figure away from the rotation center. Oh, by the way, you may have noticed that the affine transform object is put into the graphics 2D object every time the transform is modified. This is necessary because the graphics 2D object makes a copy of the affine transform that you pass to it. It doesn't keep the address of the original, so changing the original will have no effect. The result looks like this. This shows the complete circle of the figures. Now, it's also possible to draw the figures around the new center of rotation, but have each individual figure retain its upright orientation. This example uses two affine transform objects. I think the easiest way to explain what's going on here is to explain what happens inside the loop. This transform, the AT transform, is set to translation of the origin to the XY points defined in the array named F point. Now, as you can see here, the F point values are defined with X set to 100 and Y set to 0. That means that this translation will move the origin 100 pixels to the right. But before the translation is made to F point, a translation is made to the center of the window. That is, this transform will move the origin to the center of the window and then on to wherever F point directs it from there. Now, this is where this transform is set into the graphics 2D object and is used then to draw the polygon. Now, here's the part that's new in this example. This call to transform is a bit different. As its input, it accepts an array of x and y coordinate values and an index into that array, specifying which member of the array is to be transformed. And this is the output. The points that were found in the input array beginning at the offset index are stored into the output array beginning at its offset index. In this example, the output location is the same as the input location, so the new values are simply replaced by the old ones. This last argument specifies the number of x and y values that there are in the array. You can transform an entire array of points, but in this example, we've just got one xy pair. Now, this transform is set to rotate the points 1/16 of the way around the origin. So here at the top of the loop, the center of the figure to be drawn is translated to the point specified in F point. The F point location is being rotated about the origin. So that's what this translation does. The result is that the center of the figure is being rotated around the center of the window, but the individual points inside the figure are not being rotated. They just become translated to the new location. The result looks like this. So the figures are being drawn in a circle around the center, but the individual figures are not rotated. Okay, one more. This is just like the last one, except for this method call right here. This rotates each individual figure before it's moved to its new location. The amount of the rotation is pi over 2, which is 1/4 of a complete circle, plus 1/16 of the circle times the loop counter. Each figure is rotated slightly more than the one right before it. The result looks like this.